So in the previous video, we have dealt with the methods that are involved in differentiation. We mentioned the general method, the general rule. We have the first principle. We have the quotient rule. We have the implicit rule, and on and on. We have 6 basic rules, and we have delved into the general rule. So this is some set of questions we are coming to use. We shall apply the general rule in them just by doing some other alteration inside the question itself. Then in the next video we will look at the first principle. Without wasting time, let's get into the video. Alright? So the first question is this. Solution. Y is equal to 3x exponent 4 plus 4. So in this question, we are asked to find the y, the x. Now look, I mentioned earlier that the y, the x is equal to f prime of x, and this also is the same as y prime. So any question that they ask and they say find f prime of x or find y prime or find the y of x, they are still asking you to differentiate. They are still asking you to differentiate. And this is very applicable in life situations. Like you are traveling, you want to know how long the journey will go. You know, the car can speed 1 kilometer per hour. So you're able to know that this is the number of hours I'm able to cover 5 kilometers. But here's the case, the road is not smooth. Secondly, there are cars or there are other vehicles on the road. So the car cannot speed always at that particular capacity, 1 kilometers per hour. So it means it will be accelerating and deaccelerating at a point in time. And it is only calculus that can help to calculate the approximate hours that they are going to spend to reach your destination. And that is why this is very, very important. So without wasting time, let's continue with what we are solving. So this is going to be equal to the first, or the general method says that if I have y to be equal to x exponent n, what I have to do to find the y, the x, I must pick the numerator here, that's the power, and multiply by the whole function. So I have n times x exponent the n. Now I subtract 1 from the exponent, so minus 1. And this is going to equal to n x exponent n minus 1. That is from the general method. And this is the method we are going to use to solve our question. Alright? So without wasting time, let's get it. So here we now have 3x exponent 4. That's the first step. This is content. So I have 4 multiplying the function. Now I subtract 1 from the exponent. This is plus 4 exponent 2 exponent 0. Now when you look at this, you realize that we have this as a constant, because if there is no variable attached to that particular number, we call it a constant. But I want to introduce this x, it's also having an x, so that you know why it is so. We know that any number raised to the power 0 is 1. So x to the power 0 is 1. And that means you still have what? 4. But the principle is saying that we multiply the exponent, that is the power, by the whole function. So it means that if that is the case, I can have 0 multiplied by x, 4 exponent that. Now subtract 1. We go ahead. 4 times 3 is going to be 12. Exponent, x exponent 4 minus 1 is 3. Plus 0 times this whole function becomes what? 0. That is to say that if you are differentiating a constant, when there's no variable, there might be a variable there, but it is not with respect to x. If there's no x there, then it becomes 0, because we are not differentiating with respect to that particular variable. Example, if I was having, let's say, y is equal to 2x exponent 2 plus 4y or 4t. Let's take it this way. So dy dx is going to be equal to, I'm differentiating with respect to x. Therefore, I'm considering this. So 2 times 2 x exponent 2 minus 1 plus here, because there's no x, we round it to 0, because we take it as to be a constant, because there's no x we're going to do. So automatically it becomes what? 0. So your final answer is going to be 4x in this particular scenario. So once you are differentiating with respect to x, then this becomes a constant. If I am differentiating with respect to the t, then this becomes a constant, because t is not inside. It is rather going to be, so dy dt is going to be equal to, this whole function is going to be 0 plus 4, because when I have 4t minus 1 multiplying this one, it's going to become a multiply. So we have the answer to be equal to 0 plus 4. 1 minus 1 is 0. Any number is power 0 is 1. So the t is already 1. And we have the answer for 4. So if you are differentiating with respect to the variable, that is what you handle. Alright? So our final answer is self x exponent 3. That is it. Now the second question is b. Y is equal to 2 plus x exponent 4 exponent 4. In this question, what you have to do is still to apply the same principle that we are using. There is an implicit rule that you can apply, but because you are not done with it yet, we will use the general method. Then we can simplify it down. So let's assume that this is a whole one variable. What you have to do is subtract this. So my dy dx is going to be equal to, we multiply by the exponent or the power with the whole function, and we subtract 1. That is the first thing, because we are treating this as a whole. And then times, or we put a dot. You differentiate what is inside, still using the general rule. So we have differential of this 2, it gives you 0, so it's 1. Plus differential of this, that will be 4 times x exponent 4 minus 1. This is the one we are dealing with. So we first differentiate the whole function, which is this, and differentiate what is inside and multiply it. So this is going to be equal to 4 in the bracket 2 plus x exponent 4 all exponent 3, but 4 minus 1 is going to be 3. Right? Multiplying by 4x exponent 3. Now this is multiplication, so I can bring the 4 over there. So 4 times 4 is going to be 16. Bring the whole thing there. 16x exponent 3. From the bracket 2 plus x exponent 4 all exponent 3. And that is how we deal with this particular question also. Easy and simple. So simple. Take your time and go through the video. You can pause it and pause it. If you have any questions, quickly use the comment section and I will explain it easily to understand in another video. So we look at the last question. Now the last question, to differentiate it, we need to understand some laws of indices. To deal with the last question, we have to apply the laws of indices. So if I have 2 exponent negative 1, it can be rewritten as 1 over 2. The negative round to 1 we have over 2. If I have 3 exponent negative 2, I can write it as 1 over 3 exponent 2. So applying this indices principle here, I can rewrite this same function as y equal to x exponent negative 3. The exponent here becomes negative 3 plus 4x. We have not done anything to the function, it's still the same. Now we come to do the differentiation. So we have the y, the x to be equal to, applying the general principle that we have dealt with. So I've multiplied the function with the numerator, so the exponent, to negative 3 times x exponent this, and subtract 1 plus 4x 1 minus 1. Remember, you are multiplying by the exponent, which is 1. And 1 times any number is still the same. So when we are working mathematically, so when it's 1, we don't actually multiply. So this is going to be equal to minus 3 x exponent minus 4. Minus 3 minus 1 is giving minus 4 plus 4x exponent 0. Right? And any number is equal to 0 is 1. Meaning that our answer is still going to be this plus 4. We need to rewrite this in the form of that. Now we said that if it's the exponent of negative, we can rewrite as a fraction. So note, it is only affecting the x, not the entire 3. So I can rewrite it as the 3 is still there, but then I have 1 over x exponent 4. We have changed the negative into the fraction plus already 4 there. So this 3 is now multiplying the whole thing. Remember, it's multiplying. So it goes up. So negative 3 over x exponent 4 plus 4. And this is the end of that particular question 2. So my dy, the x is equal to this. Now notice that when I am working until the other side is going to be different, the equal sign can run to. I don't have to write the same thing too. Right? If I'm writing the implication sign, so I can put it implies that this is equal to. So this is it. In the next video, we will look at the first principle and we'll solve more examples like combining the same. Don't forget to give me a like, share, and subscribe. You can help me